Thanks so much for joining us. Delighted to do this with the three of you. This is actually our attempt to actually bring real operators, real builders inside uh, in a candid conversation on just real issues that you guys are facing in the business and your perspectives. And where better to start than AI, which is kind of grabbing everyone's attention. So Dheeraj, we'll start with you. I have a question for you, which is what's the one thing about you that most people don't know? And then would love for you to maybe talk a little bit about what an AI native company means to you.
Wow, that's a difficult one. You started. First of all, it's a pleasure to be here. Thanks to both of you to really do this. And I mean, today was one of those tough days. I'd called you and with a bad news saying, I don't know if I can make it. And then I could. So thank you for being flexible. And thanks to all of you for being here and everybody who organized it too. So the one thing that people don't know about me is probably the way I met my wife.
Okay.
And this was 1997. I was barely 22. And I come to this country, and the way I meet her is extremely serendipitous. She's like 8,000 miles away, and we meet in a chat room.
No way.
Yeah. And then we chatted for the first day for 9 hours, and I start calling her and there's a room in that chat room.
Was called ICQ or something?
No. There was no apps. You had to download, for those of you, I'm aging myself now. It used to be a Java applet. So there was a whole applet that would download on a browser. And the room was called Bombay. And I'm like, it's some relatable names here. I'll go ahead. And then I start calling her 3 weeks later, and we long distance date each other for 3.5 years. And then we get married, So
wow.
So that's the little thing about me. And now we have 3 kids. We're married for 25 years now. So
it works.
Yeah, it does work. It does work. And what was the second question?
Just what does an AI native company mean to you? I mean, there's so much. Everything's AI. Everyone's AI.
See, I think I'll start with culture, first, because when you build a company, everybody just wants more people. But I need these people, I need those people, and the tech is not here, and what can we do about it? So if anything, coincidentally, I was thinking about it today, and there's a crawl, walk, run with what AI really means. And in many ways, I like the power of 3, and I'm like, okay, these things have actually looked like, there's a role for very small models, 100 million parameter models. There's a role for 10, 15, 20 billion parameter models, and there's a role for a 2 trillion parameter model as well. So there's a tech piece of this, and if you're ambitious, you'll say, I go beyond prompt engineering to vector databases, which is RAG, and then I go from RAG to doing RAG on everything, not just documents. So there's a continuum, and finally you're like, okay, why do I actually need to do fine-tuning and supervised fine-tuning and things of that nature? So there is a whole continuum, and different people in the company will need to sit at different places. Because there's a role for prompt engineering, especially people who are building workflows and automations, and including the non-techies can do a lot of that because English is the new language, programming language. But then a lot of the developers have to start thinking about vector databases because you have to map everything to n dimensions, and what does it mean to, because that's what connecting the dots used to mean for experienced people. I can connect the dots, like machines can now connect the dots as well. And unless everybody thought about n dimensions, it's hard to really think about adjacency thinking and such. And finally, what does it mean to really beat the machine and do synthetic data and fine tune and all that? Because there'll be a time when RAG won't work and prompts won't work. So you've got to have specialized models, and those are mid-sized models. But if you take a step back from all of that, there's tech, there's continuum, there's understanding the crawl, walk, run of this. But as you build the company, how do you really impress upon everybody that you don't always need to hire people? You can actually do this. Like today we were talking about, for example, knowledge. Knowledge is a big deal in any company, even if you have 3 people or 30 people or 300 people. And technology is basically limited by the quality of data. We know about this, and AI is tied to data in a big way. But we start talking about Q&A. I'm like, we don't have enough Q&A for support KB articles and things like that. They're now stuck at review process for humans and things like that. And I realized that we actually have a little bit of a class system, that we actually have a much higher bar for machines And the fact that they could be doing this or that wrong, I'm like, when we hired these young people and they're not fully trained, we are actually willing to do more risky things with them than we are with machines. So we have to basically make sure that we look at machines not as adjunct to people, but say, look, they can help in many ways. And if you're giving people a chance, you should give machines a chance as well. And finally, I'm thinking about like what does it mean to change culture and have more and more people write prompts. At the very least, that's the least they can all do, including managers. So there's a slogan that I kind of came to my mind today. In 2010, some of you probably might remember 2010. We had this ad from Apple. Look, there's an app for that.
Yeah.
So I'm like, what about if there's a prompt for that, as opposed to I need to hire a person or something. Yeah, an agent is still too sci-fi and stuff like that. We'll talk about all of that, but I feel like, at least for most people, a prompt is English and it's relatable. An agent still needs to be defined and such. So anyways, I think that to me is a lot of the foundation of what AI native is. We'll talk a lot about data and why data matters for this AI, but really fascinated by this word AI native myself.
Very cool. Riya, coming to you, what's the one thing about you that most people don't know?
That's a good question. I camped in the Arctic for about a week and almost died in a storm. So
intense.
yeah, that was an interesting experience. But I think.
And give us a vibe of like, I mean, you're on Stanford campus, and everybody's building AI. Everybody's talking AI. There's of course incredible research happening. Like, what is the vibe?
I think everyone's excited again. I think there was always, obviously, you're at Stanford, a lot of people are very excited about building. But I think what I've noticed is there's like a newfound interest in like technical like details and like complexity again, that it doesn't feel like, I think one of the things that I was interested in was like that technology gap and this gap in like consumer needs. And I think that's when you saw a lot of companies like DoorDash and like Uber and things come out. But now I think there's a new focus on very difficult technical problems again that I've noticed like a lot of my friends focusing a lot of their time on. And I think with AI, it's not just like you're coming up with like a company or working on a startup in AI, but I think that it's a really great tool that you can apply to other disciplines. So my background's in like biology and computational biology, and all of a sudden, you can apply to very interesting problems like in that space, like especially like research in like material science or like Raman spectroscopy or protein sequencing. And it's nice to see a lot of people, even if they are from different backgrounds, join together and talk about this like unique tool as a way to solve them.
Very cool. Mehak, coming to you, what's the one thing about you that most people don't know?
I'm a huge water baby, but I don't know how to swim. But I've been kayaking, snorkeling, surfing, all sorts of water sports. Life jacket for the win.
Well, I'm glad you made
Wow.
it.
You are brave, by the way. I say that.
Tell us a little bit about Sybill, right? I mean, you were in the middle of all of this, and it becomes real, every day at 8 a.m. when you check into your office. Like, what's Sybill, and tell us a little bit about kind of like how you think about what an AI native company is.
Yeah, sure. So we started Sybill in 2020, before AI was cool. What Sybill does is it's building an executive assistant for sales reps. Imagine as a rep, you are essentially trying to tackle like 20 different deals, which are in 20 different stages of conversation at the exact same time. It is very hard to keep all of that context in your mind. And what Sybill does is that it will, every time you're jumping on a call, it will search your CRM data for you, your past calls, your LinkedIn, and give you like, here's a pre-call brief that you can go in with. While you're taking a call, it will take down all your notes. The moment you step off a call, it will have your to-dos ready for you. It will have your follow-up drafted. It will have the first cut of your collateral. So basically, if today you're trying to handle like 20 deals at a time, with Sybill you can handle 100, and with much better win rates. So that's essentially what Sybill does. And where we started, and this is how the AI and all of the things became very real for us, we started with building nonverbal cues. So we wanted to read the room on Zoom. So which means trying to detect when someone is surprised, when someone is happy, are they resonating with your pitch? And the kind of insights we surfaced, for example, if I'm trying to pitch you something and I say the price of this product is $1 million and your eyes go this, it is something we would catch. But that is not something what a seller will relate with. What LLMs did for us, it gave language to this sort of AI insight. So what we could tell this seller was that you're dealing with a price-sensitive customer. And that is what resonated. And that is how like the whole UI UX now comes to being a true assistant. You could have any sort of insights in the background. If you don't speak the language of your user, none of that is going to come to life. And that is basically what an AI company is for us and what it did for going from there.
Anything Dheeraj said that you disagree with?
I think at some point in your conversation, you talked about prompts and how they are like, being able to be a good prompt engineer is becoming more and more relevant. I believe how the technology has evolved, especially with reasoning models and with agents, prompting is and being good prompter is essentially becoming obsolete because you needed good prompts before because you wanted to explain to an LLM how the reasoning will work, what is the chain of thought, do this, assume this persona, all of that. Now with agents, either it is going through multiple rounds of reasoning and LLM by itself, that it can recognize that user intent versus being explicitly out there.
Yeah,
And
I
hence
think-
prompts become lesser in value.
Yeah, I mean, I actually would be shocked to say that. So, I mean, we build agents a lot for our customers, and in fact, we're building one of the most difficult agents, which is a professor of HBS. He is a psychology professor, and we're trying to build an avatar for him.
Yes.
So let me tell you what agents are, at least our definition of it. I think at the end of the day, there is a gigantic, model that's out there, which is a foundation model. The kind of context that you can provide it, is at some point only going to be through prompts. At least today, it's only through prompts. You can't take a 2 trillion parameter model and give it context any other than prompts itself. And of course, as I said, at times you'll probably have skills attached to it, and those skills are things that could do search and vector databases and things like that. But how do you actually sequence this back and forth between what this big, neural network is actually trying to do versus what it could really do with prompts, versus when can it actually call a RAG skill or when can it actually call a workflow or tools as we call them? I think that is right now a big challenge. We don't know how to sequence these things and so on. So that's why SFT is coming about, which is like, hey, you probably will need to create a specialized model, and that specialized model is again next token based. You need to generate a lot of synthetic data for that. But reasoning is very early right now, and I don't think the big foundation models can be taught to reason on your data, on your context. At best, the thing that's really working with them is prompts. And the idea of chain of thought. What O1 is doing right now with reasoning is with the internet data, with Wikipedia data, and the public data itself. But the moment you actually give it enterprise data and say, like, for example, like giving you an example of your sales conversation, summarize an account. Right? An account is actually a knowledge graph. Basically, an account has sub-accounts, it has users, it has engaged users, disengaged users, it has opportunities, opportunities have tickets, tickets have, issues and GitHub code and all this stuff. There's a pretty, comprehensive web of things that it's connected to. There's no way today that you can just tell the large LLM that, hey, you can go and summarize this account. And how you take your object model and really give it to a large language model to say, now, can you really go traverse this, is still only possible through tools that you'll have to go and write. So traversing this object web will still be code. And I think, again, the point about prompts is still very important. There's a lot of things that you can do with prompts that needed humans in the past. So I think the reality of the thing is that workflows become prompts driven. There'll be nodes in the workflow that'll be doing speculative work like, deflect and route and attribute and cluster and classify and all sorts of verbs that humans did on a spreadsheet can now be done really well with prompts. And those things, therefore, will continue to be prompts plus generative models, while you'll probably have to really do SFT for things that really needs any kind of reasoning based on your enterprise data. At least that's what we feel the technology is headed towards.
What we have seen, so summarize an account is a very standard problem we solve. And when we think of agents, the LLM, the foundational LLM, is a very small part of it. It is actually, so for us, the major purpose of that agent is trying to gather the context, which is traversing the knowledge graph, which is going through your vector DB, which is going through your deals, your calls. And as long as you can build good systems, good engineering systems, more so than any LLM system, to be able to fetch this data intelligently, to be able to filter on the tables that you probably have in your systems of record, this context coming into LLM will get you good summarized account, which covers everything.
But
so
that comes through a
completely
prompt
agreed.
then. That comes through a prompt. I mean, at some level,
Yeah.
you will have to collapse all this stuff, traverse all these different objects that are linked together.
Tool design becomes very important. Completely agree. Tool design is incredibly important with this. Yeah.
This question, it's very provocative, right? To say that, okay, all these things that humans were doing are now happening. Sometimes in our world, we wonder if we're going to see a 10 people company doing $200 million in revenue and what have you. What are some of the breakpoints today, right? Like, I mean, where do you still need, a more traditional, conventional way of working?
Yeah, I don't know if you folks want to take a stab at it. Yeah.
So I believe whenever there is a mistake that happens, an LLM cannot take accountability, right, for something. That is when we need a human to step in, somebody who responds with empathy that, oh, we're going to fix this, I'm on top of this, or I'm going to take accountability for this went wrong, and hence I'm going to solve it. I don't think an LLM can do that, or at least not fake it well enough today, and that is like the major breakpoint of these systems.
What do you think?
I think creativity was also something that I was thinking is very unique to humans. I think LLMs are good at it, but in domains that have already been explored. So I think a good example is maybe scientific research, coming up with new questions. I think that's where having a lot of educational background helps, and as a human you do have a lot of rules in place, and that govern maybe a molecule or something, that'll determine the questions that you do ask. So I think humans are very critical to guiding what kind of research you are doing or what kind of products you're building. So I think that's one component of it with respect to research. And I think the second is product. So I think humans have a really unique insight as to what we want. What does a good user experience look like? How do you make something that's very intuitive for someone? And I think that the third part is that need finding process will always be there. And I think it's great that you now have all these tools to execute on something that you want to build. But I think actually going into someone's workplace, understanding what their workflows look like, where inefficiencies might lie, is something that a machine is not that great at. That will always need to be there.
Very interesting. It's kind of intuition for people and their world and what have you. You said product. It's interesting. One of the conversations I was having with our team was, now with these multi-agent world, right? Let's say it comes to full fruition. I mean, is product the way we think about it, UI, is that kind of dead? Because, instead of kind of having, the way I think about it is the way I discovered computers, Windows, and there's a bunch of applications on it, and you kind of hit every one of them, go do whatever you want to do, and then you come out, go to the application. Well, it just look like now, Sam, Michael, Lisa, Julie, and I kind of just route them, and so there's no real kind of need for product. So
I'll actually say it differently. The other way to look at this is that, and if anything, with what we saw at DeepSeek, models will commoditize because open source is here and people will build on top of open source. So what remains is the data and then the surfaces. And we'll talk about surfaces. It doesn't have to be the old complex app surfaces, it could be starting with a command K that actually starts that way, and then it probably grows from there. But surfaces will matter because we're still dealing with humans as well.
Yeah.
It's not like machines talking to machines and doing business with machines. But data itself is a very hard moat, because you need to understand, object models, security model, event models. There's lots of models, even though it's not the large language model. You need to think about even SQL model, because text has to convert to SQL as well. So there's lots of models that matter with respect to data. And I think on surface, first I look back at the last 15, 20 years, and we said Windows is dead. And then we said, long live Windows, because in the business world, it was still very relevant. SQL is dead. Long live SQL. Right? So we look at all these things and we say it's actually dead, but in reality, they both will coexist. So for specialist people who are really specialized in doing a few jobs, one has to realize that they need to repeat it so many times that they would probably just go and do 2 clicks rather than type 50 characters on keyboard, or even say the voice thing, because voice is also probably getting as important as text. So I think there will be a role for a generalist surface, a role for a specialist surface. Mobile still matters in a big way as a surface. If anything, if the intelligence really comes to my phone, then I can be on the move and so on. So I don't think apps are dead. Apps just become a whole lot miniaturized, and hopefully they grow from there, depending on how generalist of a role you have or how specialist of a role you have. But data and how you really connect the data to the models will be the real moat for most companies.
You still had product managers and product people in the company?
Yeah, because as you heard. We talk about creativity. Judgment is still a very important word. At the base of the stuff, pyramid is rule-based automation. So you have to deal with, let's say, hundreds of millions of things. You probably will run them on a CPU because GPU is too expensive for that. And you're talking about maybe hundreds of thousands of things or maybe millions of things. You'll say, let's just use GPUs for that. But LLMs will actually do, especially the large foundation models, will do things that is based on their ability to, let's think about sentiments and, moderation and evaluation and things like that. So they'll probably be very good at that. And then you'll say, well, I'm going to do specialized models, and, you'll have smaller models for that. And then eventually the real specialized model is the human, because that's the epitome of judgment, So you'll still have people do a lot of that. Now, how long this takes, this won't happen overnight. We've been talking about paperless office for a very long time. We still have a lot of paper. It's been 30 years since we talked about paperless office.
Paperless office, okay. I'm going to remember that.
Yeah. So I think this is a 30-year journey as well. We've talked about autonomous cars for like 20 years now.
Yeah.
Tesla started talking about autonomous cars like 18 years ago, 19 years ago. And we still know where we are. It's probably less than 0.1% of the cars are autonomous, So I think the important thing is, can we look at it like Tesla or Waymo? Because one of them just collected a ton of data along the way.
Sure.
They have tens of millions of miles that they can actually train their models on. And the other one is a little bit of a stickler, saying driverless is the only way to do this. And I think
I'm much more focused on kind of integrated and sophisticated hardware.
Yeah, and they still don't have a business model yet. It's like, okay, taxis, and maybe in the next 10 years, you'll do this with taxis. But I think Tesla said, look, we can actually start with level 3 and level 4 before we really talk about level 5. So we're going to have to think about that kind of trade-off as well when it comes to what agents will do and what humans will do as well.
Very interesting. You sell into GTM, and we were chatting a little bit before the panel about. It's not a panel. We were chatting a little bit about the importance of quick GTM, and you have a little bit of an advantage. I guess what I'm just sort of wondering is that at least as a consumer, if now somebody is writing me an email or whatever it is, I just assume it's a bot, right?
Yes.
And so, how do you think about GTM teams any differently from, let's say, at an AI native company, right? Versus, let's say, something that we are more used to. Sales also, I would say, like, again, one could argue is like half science and half art, or 70% science and 30% art, depending on who you talk to. I'm just curious, like, how do you kind of conceptually think about go to market, like marketing, product marketing, sales, funnels?
I think one thing that we now have a little differently is in the past, innovation was very like you have technical innovation, you have product innovation. I imagine now that the technical moat is no longer a thing. It's just technical advantage, and that too maybe 3 months, 6 months at max. Uh, Innovation cannot just be restricted to your product and engineering teams. You need to have at least one innovation in your GTM. It could be the way you price things, it could be the way you usage, it could be anything else, but you need that at least one innovation in that GTM team, which converts your technical advantage to a distribution mode, and that is much more sticky. And
So does that mean, like, when we used to think about ideal teams, right? There was a CEO and there was somebody who's kind of like, a deep technical person. Like, now, do we need this, somebody who really understands GTM and kind of like at the forefront of it?
I don't know if you've heard of this new title that's coming up. I think Clay has made it famous, GTM engineers.
GTM engineers.
Yeah.
We used to call them growth engineers. It's just.
And Dheeraj, you were in some ways the original thinker of, kind of bringing GTM and engineering together. I remember the first articulation of DevRev, and I honestly couldn't get it. So is it still the same? Is it changing? Like, what is it?
Look, at the top of the funnel, when you have lots of interactions, machines will help. But as you go to the middle of the funnel, maybe computer use models will help, because POCs can be done like click, 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 like, oh, let me show you against my competitor. But at the bottom of the funnel is the human-to-human relationship that will matter. Especially if you're talking about anything more than a $50K deal. Like, people will get fired if they actually write a check which is $50K and the product didn't work, especially if it's a non-cancelable contract. So I think where we'll see a lot of AI is, like, for example, contract negotiation, legal work and things like that.
Deal desk.
Yeah, and it's a lot of copy paste,
Yeah.
a lot of copy paste. It's going to be deltas on existing templates and things like that. Models are good at that. When you give them a template and you say, look, now go and build something with this delta added to it. Creating this document should take, seconds, not like the way you used to do with contract lawyers and things like that. So I think we'll probably, which is the inverted pyramid in the funnel, we have to see that, look, here, there's going to be a lot of interactions, and we have to make them meaningful. Right now, it's pretty junk. I think outreach as a tool is junk right now. Like, pretty much, what you do by just spamming people. So how you bring more context into emails, where the first line, the subject line is actually readable. See, because the number I've heard is that every day, this spam machine, not just them, but every automation tool out there is probably sending 500 billion emails, because email is free. See, you don't. Apart from the fact that you're burning, cloud computing and stuff like that, it's actually free.
So everybody gets like what, 40 emails, because 8 billion people, even if everyone's wired, like that's
Well,
why.
think about it. Basically, LinkedIn InMails, 50 a month. So you have to be very, very judicious about how you burn those, right? I actually love that, because now you have to really be thoughtful about who you're going to send this to. You'll research more. And in the other end of the barbell is email. That's, you just jam SMTP servers around the world. Who cares? So I think they'll be at the top of the funnel. We'll probably bring more context, more meaning, and hopefully email becomes usable again, because email is useless right now.
But you're just double clicking on that. So top of the funnel, like more marketing driven, whether it's account based, whether it's, programmatic. Do you is it fair to say that that's the layer that'll, let's say, benefit the most from AI in the medium, short to medium term?
Absolutely.
And so the marketing teams might actually be far leaner than you've needed to have them in the past, right?
Well, look, I feel like product building is easier now. So the noise in the market is easier now. So marketing teams will still have as hard a job, because you're adding more friction to the universe, right? So to actually cull through all this stuff and be the one that's specialized, differentiated, and is able to really rise to the thing. I think for every action, there's an equal and opposite reaction. So I don't think marketing has an easier job because of this, is all I will say. I don't know what you folks feel.
It's much more difficult now, for sure. Like with the amount of noise, it's crazy hard.
And 20 years ago, we didn't have these tools, so there was less automation, but
Yeah.
it was easier because there was less noise as well. So again, it's a lot of this is just karma. We brought this upon ourselves, and the amount of friction is still the same.
And Dheeraj, you ran a company before the kind of the AI Cambrian explosion, and now you're building DevRev, right? Is there something you're doing differently about the org? Like, for example, when you think about team's productivity, when you think about, hey, when should I hire a first sales guy, or like my first AE, or my 50th AE, or how you think about quotas, how you think about like, the ratio between marketing and sales, or, engineering and like, what is the biggest delta, if any, in the way you're constructing teams today?
Yeah, I mean, look, my first company was a fairly linear company. It's still $20 billion market cap. So I'm like, a linear company, but we raised $2 billion. And I could have done it for maybe $1 billion, as opposed to raising $2 billion. Now, we didn't use the $2 billion. We only used 800 million out of the $2 billion. But it was a fairly linear company. Now, the superlinearity came in the large enterprise.
Sure.
So I'm like, okay, one rep can get me $100 million a year. That's
Yep.
superlinearity, right? But there's more opportunities for superlinearity in companies, like in engineering as well, like marketplace thinking. The fact that you can have many people from outside can come and really build these things is the superlinearity you need, where arm's length. And now with AI, it becomes possible. Like App Store had this, but it was consumer apps, so who cared if there was a long tail of crappy apps in there? In the business world, you probably need to have much higher quality. And up until now, like Atlassian suffered from this. Like they're like, oh, there's all these partners who build these apps, but now that we're moving to the public cloud, it's all junk, and nobody wants to take ownership of these apps. But now with code gen and with unit tests, I mean, the fact that AI can evaluate a lot of this code and stuff like that, I think that the next 10 years, marketplaces will actually gain a lot more prominence, and you can see a lot more. You won't have a lot of committers, but you can have a lot of fewer people who can build these things, but they're not part on your payroll. So not being on your payroll and yet getting all this leverage from the community, I feel like that's the thing that needs to really shine for great companies. And I built a good company last time, but to really build a great company, you need to have superlinearity in at least a couple of ways.
Riya, how is this influencing how people think about what to build or their careers, right? Because Stanford's kind of like the center of a lot of good technology that's come out, and then in the same vein, right? It cuts both ways, because now some of these, let's call it more generic, right, tasks are getting like more automated away. I don't know which famous person said it, like, but they said basically, I won't ask a young college student or a young school student to now learn coding, right? Because it's no longer necessary. I think we spoke about English as a new coding. So what does that mean for a young engineer today?
I think for me, it's raising the bar to which I want to hold myself. I'm studying computer science, but I think it's really important to have domain expertise in another field. And I think that's where like the hard sciences and engineering will play a very important role. I'm very interested in like material science research and like molecular biology and bioinformatics. And I think you need to apply coding, machine learning and AI to something. And I think the other part of it is I think it also encourages me to focus myself on tackling harder problems. I think at Stanford you can work on something easy and build something that you want, and I think there's a lot of value in that. But I think there's also a lot of excitement and interest in working on something that's more technically difficult. And I think with tools like LLMs now, it also makes learning about a lot of harder subject matter a lot easier and more accessible. So it empowers you as like not only a builder but a learner, and I think like increases like the possibilities of like what you can like dedicate your time to.
Yeah, I think it's very, I mean, what you just said, it's music to my ears, because I think there is a moat coming again for engineers, And this happened in the 80s when hardware was being built. You had to build operating systems. Systems were hard problems to solve. Building companies around systems and engineering was a hard problem to solve. So what is happening right now? I tend to think of what we're trying to do by giving more from expending human energy to GPU energy. There's a transfer of energy that's going on. We're trying to like, can they expend the energy that we used to? Now, in the long run, this is great. In fact, I was talking to my friend who is the chief economist of a very large bank, and he's like, in 1870s, people would work 100 hours a week.
But we're back to
And the legal age for work was 12 years.
interesting.
Yeah, so obviously in the next 100 years, ever since Industrial Revolution and all, I mean, we've just improved our lives, and our lifestyle as well. So if you folks want to only work 20 hours, that's not actually a bad sort of dream to have. I think in the next 50 years, we'll probably be at a place where we'll self-actualize and say, why do we need to work 80 hours? We probably could work 25 hours as well. But the journey is going to be hard, and that is where the moat really comes in. Because as we transfer this human energy that we're expending on rote, repetitious things and complain about work-life balance, it's probably going to take 50 years to get fixed. But along the way, as we build hardware, we build operating systems, the technical difficulty in going through this and passing this sort of baton from humans to GPUs is probably worth it.
Interesting. Mehak, question for you. Like, DeepSeek took the entire valley by surprise. What do you make of it? I mean, there's so much speculation, so we can speculate as well. What do you like? I mean, you and I come from India, right? And so does Dheeraj and Riya. Although born to immigrants, there was this kind of like inevitability that look, you could innovate on whatever, this language model, that language model in a part of the world, but ultimately, unless you have crazy compute, right, you're going to be irrelevant, right? It's kind of like commoditization with scale, right? A little bit like what telcos have done in the past, and kind of like building a bunch of backhaul, etc. What happened?
So I was thinking about this, and of course we have three big things they did, and we talk about those three big things. But it took me back to, at least I'm a big student of history, so also computer history as well. The 70s, we had massively large computers.
Correct.
And they would do batch processing. We used to call them mainframes.
Sure.
The thing that broke them was operating systems, which would do memory management and CPU scheduling, and they would take less hardware and just fool people or processes into believing that, hey, they're going to get all the machine. So there was a layer of software that came and did a lot of these things to say, look, put some constraints. Like, what if we only had small hardware? How would we actually share the small hardware across multiple processes and applications? Was the whole trick of operating systems. What DeepSeek did is obviously a one-off. They didn't try to make an operating system out of it. Like, for example, out of those 670 billion parameters, only 31 billion are active at one point. Like, hey, we can keep that in memory and leave the other 90% of it outside. Is basically what Unix did. They said, look, we can do paging in and out. The pages go in and out. So we don't need expensive memory to build these very large machines. We can have smaller machines. And we know cleverly how to bring in fault in pages and fault out pages. That's one of the big things that these guys did. Similarly, they're like, well, we have all this wastage of, 32 decimals. We can actually bring this to, 8 decimals, and all of a sudden, nothing changes about it, I think, of course, doing synthetic data by looking at the traces of another open source or even OpenAI. I mean, the point here is that we'll get into this point where countries and people and teams will say, what if we had constraints on hardware? How would we think about this differently? And that's how people moved out of mainframes into smaller systems. They put constraints and they figured out sharing and indirection and caching. Remember, the only two things that matter in systems, indirection and caching. You can solve most things in life with indirection and caching. And that's what DeepSeek did.
Fascinating. What strikes me about this, though, is that all the innovations spoke about, like whether it's, smaller computers, Unix, and what have you, all came out of the US, at least, in that historical context. And now it's kind of like interesting that, suddenly two standard deviations away from like where everything is happening, and, the president announces like this big, massive compute. Um, it kind of like just popped out of somewhere. I mean, when I think about Artbird, like it's fascinating because our whole idea is that the geography of genius, the geography of innovation is far bigger than what we are used to pattern matching here in the Valley. Why is that happening now? Like I'm just trying to figure out, like, I sometimes ask people, like, if DeepSeek came to the US and they said, hey, I want to raise $6 million or $7 million to train an LLM, would they get funded?
Yeah, no, you're right. I mean, and at least sanctions to me
Yeah.
creates necessity,
Yes.
which begets invention. So if anything, we are fueling the thing that we don't want to happen.
Interesting.
Or something,
Yes.
Sanctions.
Creativity and constraints, always. Yes. Just on the DeepSeek side, just purely on the product side of things, I think it did two contrarian things. One thing that it did was that given they trained it so claimed with such less, money expenditure, it's made like a lot of startups who thought foundational layer was untouchable or you could not train your own models as like at least go on that journey. Maybe we can do that because we have data, we can get more data, and it is a possibility. And on the other side, it also made it a lot more improbable that people would touch or do something on the foundational or LLM layer, because now it's like there are constant innovations that are happening. You would want to focus your research and your energies on something else. Because the pace of innovation has stayed, so you would rather just leverage what other people are building. So it's almost contrarian to, I was wondering about this and I was like, okay, which side of the spectrum do I lie at this point in time? And that was very interesting. I think the second thing, and this is true for obviously DeepSeek as a reasoning model, this is true for O1 Pro Mode and all of these other like class of models that has come out. I think before we used to just talk about things in terms of, when we evaluated LLM quality, we thought about quality as like hallucinations or something wrong coming out of LLM. I think what reasoning has done, it's no longer that LLM will talk about something false. It's just that with reasoning, the amount of generic stuff that this LLM produces will go a lot down. So that is what increases quality versus something very factually being right or wrong. And I think that is like a very unique characteristic of reasoning models that I don't think the general LLMs have, because they go in one shot. So by the end of it, you're reading more and more generic stuff. In reasoning models, that does not happen as often. So
what this reminds me of is when I was in primary school in India. My mom always said, if there's a math problem, do it step by step. You'll make fewer errors. And by the way, even if the answer is wrong, the teacher will give you some points for getting, maybe half of the way there.
So that's the way they're training it too, by the way. And it's, basically the teacher model,
Yes.
and they're the student model. And the teacher, and you can do it with lots less synthetic data.
Is it a mummy model?
Well, it's basically the same thing. It'll actually slap you and say you're going down the wrong path. Because look, all they're doing is next token.
Yeah.
Right? So like, hey, stop, you're going down the wrong path. This is a better path and so on. But I don't know, what do you think about what happened here? And,
I think what's exciting to me is that DeepSeek is open source and it's a lot more accessible for everyone to use, and I think what that can encourage is a lot more competition in reasoning models. I think the other thing is, like you mentioned, it's really good at coding and math problems because you have a very defined problem space, and then you can easily say this is correct and this is wrong, and it's really good at handling reward functions. But I think what I would be more curious about is how can you apply it to domains beyond traditional spaces like math and coding? Can you start to use reasoning to maybe, I don't know, come up with a research question, write a paper, or figure out how you can design experiments if you can tell it these are the rules that you need to pay attention to. So I think there's a lot of potential here, and I think it's super early. And I think one also other point that you made on the data, I think DeepSeek only used 800,000 samples. So I think, even
That's what they're saying.
yeah,
That's what they're saying.
You don't have to. Actually, with SFT, you don't have to use a lot of data, actually. Because anyway, you start with the base model. You're trying to distill it. The process is called distillation. And of course, you can go after, because you're not going after raw data. Remember, the synthetic data is Q&A. is way better at giving Q&A, which is synthetic data, than just giving raw data. Foundation models were trained on raw data. This is actually a lot more positioned and polished and saying, let's just go after Q&A itself, you know.
It's like the big model and the one in the middle and then the very
And by the way, you
particular-
can give it even less if it's reinforced. You can actually slap it and say you're going on the wrong path. You can do with a lot less data then, you know. So you will see, I think the reason why this is important is because there will be a class of people that try to keep miniaturizing it. Because at some point it should come on our phones as well, you know. It shouldn't have to be. So I think there'll be a class of, and computing's biggest breakthrough is about miniaturization.
Interesting.
You know, that's the only thing that has happened in computing. Just make it smaller, make it smaller, make it smaller. And so I think if anything, it's going down the right path, you know.
Cool.
And for a lot of industries that are very scarce in the data that they have, like I think like biotech is a big example of that. Like you're limited and like you can only conduct so many like high throughput experiments. So, you know, if DeepSeek is able to reason on like a smaller data set, I think that could have like
It's
a
a
lot of
huge
very
boon.
meaningful implications in industries like those, where generating synthetic data might not be as easy.
Also, it sort of means like a whole bunch of like longer tail problems, right? Almost like if I think about the biotech analogies, like, you know, rewarding orphan drugs, right? Kind of like catastrophic, but very small part of the population. Unless you really sort of incentivize that, you know, who would, you know, go and solve those problems? It almost feels like there are all these orphan problems that are hard, right? But haven't been as rewarding to solve. But now, you know, with this, again, in a unique way, right? Because of this ability to do more with less, you know, it's still viable to go attack those problems.
Yeah, absolutely.
Yeah. I mean, look, the underlying hardware is still next token. So reasoning is not a new thing. Reasoning still uses next token. You're just giving it, you know, enough and making sure you can go and fine tune the weights of the underlying neural network. And in fact, there's something about plasticity as well.
Say more.
Basically, just like a brain, like, you know, once you're 30 years old, it's hard to change you. But when you're 12, 13, 14, 15, you know, you're going to absorb a lot. It's equally true for the size of the model that you can go and fine tune. You can take a very large model and fine tune it because it has all the biases in the world now. It's become so big with so many neurons and so many of these.
Too much wisdom.
Too much wisdom. So even knowing the size, the Goldilocks, I think the size that they actually picked to fine tune is also very important in this. You know. But it's still an underlying hardware is still next token. So you know, we just have to be aware of how we're shaping the next token thinking by giving it synthetic data and such. You know.
Very interesting. What's the one thing about AI that you kind of like privately believe in, that, you know, or you experience, you know, building a company or going after problems that's kind of like, you know, not many people appreciate, or, you know, the narrative is sort of, you know, very, very different?
I do believe like humanoid robots are like coming definitely soon. And just like with LLMs, it was like nothing and then all at once. I think once somebody cracks like, you know, some like one level of basic task, but it's very general purpose, it's gonna go like this. And it's gonna see the same sort of hockey stick.
Are we there yet in terms of like the brains? The brains.
Brain. I don't know, but I don't think we are farther than 5 years away, like max.
It's kind of like what it will take is like reinforcement learning with a very, very open
Yes.
domain, right?
Exactly.
What do you think?
I think something that I'm really interested in, I was talking to one of my professors and he said he dropped out of his PhD because he was really book smart, but didn't think he was creative enough.
Creative.
And I think like when we're prompting ChatGPT right now, I think a lot of what it says like are hallucinations and like it might not make sense like if you're like in a scientific field, but I think there's a lot of opportunity in like trying to leverage like AI for creativity. I think that's a lot of what makes humans human. So I think investing more energy in that and like using it as kind of an assistant to yourself as you think about new ideas would be really cool.
So using it for creativity versus kind of these very discovered problems.
I think for me, you know, I love driving. I don't know about you folks, but I love driving. But I'm like, if I can get my dash to have my entire laptop experience, where I can just be in my office while I'm driving,
Yeah.
Just a truly autonomous car where I can sit. I mean, and I don't want to sit next to the wheel, actually. I want to be on the wheel.
Okay.
But city driving should be autonomous, everything that I want to do. But then when I want to get my hands on the wheel, it's mine. That's what I really want.
It's interesting because I've seen some renditions where they're actually moving the other way around, which is the car drives itself and you're on your laptop like working on.
But I think autonomous driving is probably the thing that we've been working on the longest. Probably 10, 12 years now. And it's a fairly well-defined problem, at least in the US. Now, if you go to India, it's a different thing. But at least in the US, it's a well-defined problem. And we're still far away. And that tells you that the inertia in the system, including regulations and liability and insurance companies and who's going to bear the brunt of this and that and all that stuff, I think we still have a lot of legacy to go after. But I think that's my dream, that, buy great cars and then still be on the wheels and still work. and yet when you want to have your hands on the wheel, you have the hands on the
I
wheel.
remember like 5-7 years ago when Uber was kind of like becoming the thing, there was so much conversation about, will this generation now even own cars, right? And so it's refreshing to hear this. I don't have any other questions, but like, the floor is open. You guys have anything to ask, please fire away. Anything that came up that's provocative, please, it's like, let's open it up.
Are you folks dealing with any of these topics in your lives right now? Somebody should say, look, this was relatable, meaningful, or not. This is a
Wow.
pretty thoughtful audience, I would say.
Almost too thoughtful.
Hi, my name is Zane. I wanted to ask more about what you meant when you said that almost everything can be solved with in-memory and caching earlier.
Well, systems, we try to look at complexity and say, and this has been going on for 30, 40 years now. We're like, okay, what did you do to solve this problem? Indirection is one way to solve problems. Like, well, don't directly refer to this thing. Refer to this thing and that will refer to that thing. Has solved a lot of problems in systems. Computer science in general, especially systems engineering, operating systems. And the second thing is caching. Know what to cache, and because performance is a big deal in a lot of these things. And we're trying to squeeze in hardware and latencies and things like that. And I think right now we're throwing a lot of hardware without knowing which pieces of the brain really need to be active right now when I'm doing things. The neural pathways that matter and such. And what DeepSeek showed, at least one of the big things they did was, I don't need to keep all my parameters in memory when I can actually go and keep only a portion of it. I think you'll see more and more of those things come about in the next 5 years as we think systems as opposed to AI. I think big pieces of AI is now systems. The more people start to look within, like what is the resource constraint that we need to solve for, the more it becomes an operating systems problem, Yeah. Yeah, that's another question.
Every day, just learn more and more. I guess what's your sort of routine? Where do you go? Do you ask? Obviously, you're pretty knowledgeable, and obviously, we use the internet and all that. But I'm just curious, how do you seek information?
And you folks should also talk about your memory hacks. I don't know. You should probably talk about it too. Personally, I take a lot of screenshots on my Apple phone. And then the best part is that it's searchable because screenshots are searchable. And I also organize a lot of them in folders. And I have a really good recall. I have articles from 15 years ago and I know exactly. So somehow I'm not good with names. It took me a while to, okay, Mehak, it's the second time. Okay, it's Mehak, But if you ask me something from 15 years ago, I'm like, okay, I know which shelf of my brain is it in. Because I organize the information in years. This year I read this year I read this, and so on. But I think organizing well is a very important piece of it. And then going back to it every once in a while. So I have quotable quotes and book blurbs and this and that. And then the fact that it's searchable on my phone is a big part of this. I think FT is a big part. So FT is Financial Times, New York Times. I try to also make more things look similar as opposed to different, because I can't remember so many things anyway. So if I can try to find adjacencies, just like vector databases, I'll remember it better. So I'm like, oh, it's not that different from that thing. It's just sophisticated pattern matching, which is what LLMs do, by the way. I think it helps to, remember fewer things. I don't know if you folks actually want to talk.
I mean, I learned medicine, I think, the first part of my life, and then I completely changed into building companies and now venture. I think a big part of like absorbing new information is like just discarding a whole bunch of stuff that you don't need. And so, I think we don't yet fully understand. Maybe there's a short-term and long-term memory sort of disconnect here, but a lot of things like are not in my mind right now, but then they'll kind of like pop up the moment something similar kind of happens. And then similar to Dheeraj, I just think like and actually I'm not technical in the same way that you guys are, and so sometimes I feel like asking the stupid questions. It's like, hey, like, shouldn't it be this way, shouldn't it be that way, or like just boiling it down to like just first principles is a pretty bruised word, but kind of like just having very simple 1+1 = 2, 2+4 equals whatever 6. That really helps, right? Kind of like seeing patterns between different industries, patterns between. Dheeraj of course thinks a lot more kind of like over periods of time and kind of like these revolutions. Maybe have a better job to do there. But I kind of like tend to focus more on different industries that also are in very, very different stages of their own sort of technological evolution, and saying, okay, like what did I learn from I don't know this enterprise company that's relevant to real estate or that's relevant to healthcare or what have you.
By the way, Steve Jobs said this about creativity, that it's not really coming up with new things, it's applying things from other realms into new realms or something, and that's creativity in a big way.
I'm ostracized in the valley for being a generalist VC. Like, they're like people like, what do you specialize in? And I'm like, that's not how I think.
How do you learn and remember?
I think two ways. One, building for me is a very sticky way of learning. So, like, as a student also, I think I was building all the freaking time. And so pick a problem, you make it better, you keep on doing it harder, you will automatically keep up with things that are going on around you. And I think the second thing, this is almost weird to say, but we think a lot less. Like, we read, and I don't know how many times you read something and you just give yourself time to absorb it and think about it and think about the first principles and the logic behind it versus just like accumulating information like anything. I think it's almost even like just like you do physical exercise, mental exercise, and just absorbing and thinking and going through the motions of that is very, very important. It just teaches you so much. So those are like my two
Very
things.
interesting. Yeah. And I can see why, like, there's so much information, so much stimulus, you kind of like flitting from one thing to the other.
What is the first principles behind every little thing that you read or see?
I think one thing as a student is it can be easy to try to learn like everything you can like from your classes and then say, okay, like I still need to learn, and then maybe you'll eventually build something. But I think what helped, and I was talking to Ira about this as well, was just pick a problem that I think is close to you, exactly like you mentioned. And I think through that, okay, you're going to have to understand the industry very well. You're probably going to be like 22 or something. So there's still a lot that you need to learn that can come through interviewing professors or shadowing someone in their job. And I think those are the situations where I learned the most. And then even like going through the process of coming up with an idea, validating it, making some sort of iteration in a prototype and getting some feedback, you learn a lot because like through that process you're interviewing someone and you're also building it simultaneously. And you're kind of also like a jack of all trades as a founder. Like yes. I was working on a project to bridge like the information gap that caregivers experienced when taking care of patients with dementia. And I had no background in regulation or the FDA, and those were things that we had to look into. But because you were forced to look into it, you did learn a lot in that process, and you also kind of developed this like breadth of knowledge as well, instead of just like specialized expertise.
And very sticky learning. The moment you build something, it's very sticky. You will always remember if you faced a problem and then you solved it.
Because we're visual, we're very
Yes.
visual beings, The other piece is what not to read. See, because we are all pretty sensitive and emotional as well, especially since social media. I've just given up in politics. I'm like, okay, I'm not going to read that stuff. It's not worthwhile. I'm not, going to affect change anyway in that sphere. And a lot of people, like, they have to be in politics. I'm like, okay, I'm so focused right now that I can't talk about things. I could talk a lot about those things, but how do you just skim through all that? Okay, that's marketing, that's the marketing, that's the marketing. And none of this matters eventually. So also knowing what not to read is equally important.
Hi, I'm here. Thank you so much for just sharing your insights with us today. I was wondering on the topic of how prompting became obsolete, if that is really obsolete, like kind of what is the next thing? Yeah.
So, and this is a little bit about how we are building today versus how we built, say, 2 years back. 2 years back, we would give a lot of like the usual prompting techniques, like give it a persona, elaborate the problem, rewrite the whole thing. I think today, what we are training our agents and our models to do is once you see a prompt, figure out the intention behind it and you solve for that intention. So, in some ways, what we have seen is that our users no longer need to give that huge prompt to us. As long as we understand their intention, where they come from, it's just like one line, 3 words makes a lot of difference. And that is how, at least prompting from a user perspective, has become obsolete. I think a lot of what you were referring to was also prompts that we would build in our system on our backend. I think those are still very relevant.
So I think what she said is again a level of indirection. So what do I mean by that? This prompt thing is basically what someone else built as a workflow or some compound bunch of steps to actually do something. Now, how do you recall it? How do you really search for it? Now there's RAG involved in it because foundation models with very big prompts, they get confused. So you're like, okay, what do I do to actually disambiguate and also help it maintain context? Because it starts to break down on attention when very large prompts are given. So then you're like, oh, now I can actually stash that skill away. It's a prompt. But with 4 lines or 3 words, I can go do a search. And there's a description of that whole thing, a workflow in a paragraph, just like App Store had apps and a landing page of an app. And you could search for that app. There are millions of apps in App Store. You need a way to search for it. That's what's emerging. Where a skill is actually packaged. It could be a workflow with a bunch of prompts. So there's going to be intelligent nodes that can call back into LLMs and get answers and things like that. But now it's a molecule that is actually stashed away, and when you say 3-4 words, I can go get that molecule back. Is basically what is going to make it easier to really compose these things into larger things. And the consumer, like imagine a company has 10,000 employees, probably 50 people can keep building these things. And the other 9,950 people can just go ask these things. And now with RAG techniques, you can get them back. Basically, RAG is going to be interweaved with foundation models through these compound things called skills. Yeah.
Almost reminds me of a library. It's like somebody
It is
walking around like
absolutely
It
a
is.
library.
Yeah.
In fact, I look at AI as a commerce problem now. You have supply and you have demand, and how do you really make demand meet supply through natural language is basically at the core of AI.
and supply being knowledge and demand.
The skills, and and honestly, even documents, I look at them as skills, like finding your Q&A in documents and things like that. So it's either fetching documents through these Q&As, it's either fetching an analytics widget, which is like, hey, the pie chart, the bar graph, I want to really look at top end customers who churn, blah, blah. Or it's looking for workflows that actually have prompts stashed in them, So they can now re-enter the LLM for things and so on.
Very interesting. Very interesting. Ira, you had a question.
Yeah, this is for everyone, but so
if you were a Stanford student right now, well, Riya, and also everyone else, what would you do or maximize at your time at Stanford?
We'll start with you.
So my background is all product AI. I would just pick something that is diametrically opposite and I would build something in that. So like as a field, say finance is not something I've experienced. I would pick a problem there, I would apply AI to it, and I will just try to build something there. And I think it will have a lot of learning and just have fun also.
What about you?
I think so. Now I'm
Well, she's a Stanford student. I'm like,
you might be better off answering
Yeah.
that question.
Well, two things. One is, and I've always wanted to do this. I would have loved to learn another big language, like like Japanese. My son, he's been learning Japanese for 3 years now, and I'm vicariously living my like teenage life through him. And both our twin daughters will probably also learn Japanese. They're picking up Japanese now. But I would love to learn a language where I can go and relate with people a lot better. But also design. See, because surfaces will still matter. Everything we just said about AI is like, okay, it's a library, it's a commerce problem. It's about how do you organize all this stuff and how do you visualize all this stuff? Our design will play a big role in this. Because, as Warren Buffett says, when the market is fearful, you get greedy. And when the market is greedy, you get fearful. I think when everybody thinks it's all AI, there's no need for humans, you're like, okay, let's care for humans. And all of a sudden, that's where the money is, really.
Thank you. Dr. V and also Riya, I'd love to know what you would do.
I was never on the engineering quad, I trained as an MD, so I don't know what I'd do differently. I mean, my world remains pretty much the same, with or without AI. I still think, I invest, I chose medicine, and looking backwards, what really got me there was kind of giving people a shot against odds, and which is why I kind of like see similarity between an ER, which is where I was, training, and early stage venture. And that's why I hate specialization, and I'm kind of like always in the middle of kind of young and things that are.
You're a foundation model.
Is that what I am? Okay. A big parameter.
Yeah, it's just generalized.
Yeah, so probably good at nothing, but a little bit of everything. I think I just get so much joy out of working with people. I would I don't think that changes much, even in a post-AI world. Yeah, it's kind of like my honest answer.
I think, like, to answer your question, optimizing your time at Stanford, especially being a senior now, has been something that I'm thinking about a lot, and thankfully have an extra year for the co-term. And I think it's very normal for all of us to see, can I do everything at once? Yes. But I think there's a lot of merit in just having focus, and it's something that I'm also trying to get better at. And I think that's when you can really go deep into something, and it's definitely what I want to try prioritizing more in the next year.
I love it. It reminds me, there's a really good treatise from 1967. Sorry, I'm such a nerd for
You're a lover of history.
Peter Drucker, who was a management professor back in the day, he talked about this problem. And computers in 1967, you can imagine how basic they were. So he would talk about the computer, like the computer is here, and he would say man because only men used to work back then. So he would use the word man and he in this treatise. But he basically said this really important thing that we're all slow to understand. It's hard. It takes a lot of, he said basically it takes 16 different ways to read the same thing. And it took me 16, 17 times to understand QKV and where is MatMul and all this stuff. Man, I don't get it. So it took me 16 different ways to look at it, 16 different Medium articles and the research papers and all this stuff. Even today when I'm reading DeepSeek, I'm like, let me go back to foundations of this thing now. So we just slow to process as humans. So the more you can look at it from 16 different angles, the more focus you actually get as well.
It's interesting. I've always struggled with focus, and I've always felt like I'm deep in one thing, and then I come back up, and then I'm suddenly interested in something else. So I'm going deep there, then I suddenly come back up. I don't know. It's just kind of there's this joy of I think somebody said, right, like finance, you want to build in finance, you know nothing about it.
Yes.
Yeah, I mean, if there's something happening that's really, really fascinating, then I'm like all in and I want to learn about it. And I'm very happy being the, kind of like the least learned person in any room and kind of like just learn more.
How about,
Honestly,
sorry, go ahead.
another thing that you could build is just build for yourself. Think of yourself as a company and build tools for yourself. Like things that can, as somebody said, right, how do you keep up with the knowledge? Build a tool that can help you, that is all your interest in, that is things that you like and can serve up something every morning as like a 2-minute treat for you or a 10-minute treat for you. Build for yourself, just your life. And that's
One
also a
more
way to
thing I'll
learn.
say is, discipline can come through health. So taking care of yourself. I mean, I don't know how much you folks sleep, but there's some really good. I mean, I wish I was aware of how important sleep is, or even breathing for that matter. Like there's some really good books. Like Breath is a great book, which is like, and as you get into the working world, and you'll see a lot of complexity arise because there's the give and take that happens with peers and your manager and your reports and all this stuff. And breath is an amazing thing. I mean, just knowing how to breathe, when to breathe, because otherwise I used to be fairly hot-headed early on. People
Interesting.
Like, man, it's like, okay, this guy is going to get angry now, And over time, just knowing of children help a lot. And once you have children, it helps a lot, You have to be patient. But breath was a big deal for me. And I realized how to pause in a meeting. Just taking a deep breath, it creates immense mindfulness. Like, what are you going to say? Because if you say something right now, you can't take it back. So breath is a very important piece. And second is sleep. There's another very good book, Why We Sleep. And everybody should read it, especially when you folks are coming out of this. It'll create immense discipline for health, your own health. And I think you'll organize your life. You'll be great at work, all this stuff. I wish I had done some of those things when I was young.
The one thing that I think you'd love, if you haven't found it already, is the Huberman Lab.
I know Andrew Huberman. I mean, I do cold showers because of him. By the way. So I don't know if you folks do cold showers. It's an amazing thing, by the way. It's tough, but I think once you get used
to it, then it's kind of like
incredible.
Should we grab dinner and we can keep chatting? We can switch the lights off and you guys can,
No,
Thank you so much for doing this.
Thank you so much for having us.
I really loved it.